Today's notes are going to be over 3-4 and function notation. And if we're going to look at our first example, we have a domain of -1, 0, 1, and 3. If you'll remember, our domain is our x values. And we're going to put those domains into the function machine, and the function machine is performing y equals 2x plus 3, and it's going to spit out our answer for the range. Our range, if you'll remember, are our y values. So in goes -1, and we're going to evaluate for y when x is -1. So I'm going to come over here, y equals 2 times -1 plus 3. We know how to evaluate an expression. We've done it in our first lesson. So 2 times -1 is -2 plus 3. -2 plus 3 equals 1. So we're going to start off our range with 1. Now we're going to perform the same evaluation for each of the domains. So my next domain is a 0. So I'm going to plug in 0 for x. So I'm going to get 2 times 0 plus 3. That leaves me with 0 plus 3 and 3. So my next number in my range is 3. Okay, next I'm going to do 1. Y equals, I ran off my page. Okay, my next domain is 1. So I'm going to take 2 times 1 plus 3. That gives me 2 plus 3. And my next domain is, my next range is 5. Okay. Next. I'm going to have 3. Y equals 2 times 3 plus 3. That gives me 6 plus 3. And 6 plus 3 is 9. So my last range is going to be 9. Now to ask for the resulting ordered pairs, remember we have x, y coordinates. Since our domain represents our x values and we've just found our range values, we can write them as an ordered pair. So my first ordered pair, I'm going to take the first domain, -1, with the first range, 1. And that completes my ordered pair. So I'm going to have 0, 3. I'm going to have 1, 5. And I'm going to have 3, 9. Function notation. Given any function, remember that y is a function of x. We're looking at equations as y equals 2x plus 3 is the exact same thing as f of x equals 2x plus 3. And that is, this is a function of x. Example 2. Find the range of each function for the given domain. Okay, so here we have a function f of x equals x squared minus 3. Our domain is -2, 0, 2, and 4. So I have to find out what the range is for each one of those domain values. So I'm going to start evaluating. F of -2 equals -2 squared minus 3. Order of operations kicks in. We've got -2 squared. Remember that a negative squared is a positive number. So I get 4 minus 3, which equals 1. So we're going to start my range off with 1. Next, I'm going to do f of 0. That's going to give me 0 squared minus 3. 0 squared is 0. 0 minus 3 is -3. So my second range is going to be -3. Then I'm going to do f of 2. What's the function of x when x is 2? That gives me 2 squared minus 3. 2 squared is 4 minus 3 equals 1. So I got 1 again. I do not have to repeat 1. F of 4 is going to give me 4 squared minus 3. 4 squared is 16 minus 3, which is 13. So my last range value is 13. Okay, I'm going to need to erase this for the next section. Okay, now we have g of x, and we can label these any letter we want for our function. So now I've got g of x, so I need g of -4. So that's going to give me -2 times -4 minus 4. We got a negative and negative, that makes it +8 minus 4, which leaves me with 4. So my range starts off with 4. Then I've got g of -1. I'm going to get -2 times -1 minus 4. So I'm evaluating each domain value for x. Negative times negative gives me +2. Minus 4 gives me -2. So my second range is -2. Okay, then I'm going to start with 2. So I'm going to have g of 2. That's going to give me -2 times 2, which is going to give me -4 minus 4, which is -8. So I have -8. And I'm going to replace my -1 with 6. G of 6 gives me -2 times 6, which is -12 minus 4. -12 minus 4 is -16. And I get -16 to end my range. Then I have my last function, h. I'm going to find h of -2. I'm going to take 7 times -2 plus 12. That's going to give me -14 plus 12, which gives me -2. So my range for function h is going to start off with -2. I'm going to take off the -2. I'm going to have h of 0. So I'm going to plug in 0 for x. I get 0 plus 12, which leaves me with 12. So my second range is 12. Then I'm going to plug in 3, h of 3. So 3 goes in for x. I get 21 plus 12. That equals 33. 33 is my third range. I'm going to take out my x value. And my last one is 10, h of 10. So I'm going to plug in 10 for x. 7 times 10 is 70 plus 12, and that gives me 82. And that rounds out the domain. Rounds out the domains to find the ranges. So I have -2, 12, 33, and 82 as a range. Example 3, translate the following statements into order pairs. Remember, this was f of x, so this represents our x value, which means f of -1 represents our y value. So if I can label that, then my coordinate pair, ordered pair, is going to be -1, 1. This is my x. This is the result, or my y. So my ordered pair is 5, 3. This is my x. 0 is my y. So my ordered pair is -6, 0. Okay, example 4, we have h of x. X is a function, or h of x. Let me start that over. We have our ordered pair -2, 6, 2, 8, 4, 10, 6, 12, and 8, 14, and they want us to find the indicated value. So they want us to find what the value is when h is 6. So that means I need to look at my coordinates, and I need to find out which x is 6, and it's this one right here. Well, what's the result? 12. So h of 6 is 12. Next one is h of 8. So again, I want to look at my coordinates, and I want to find when x is 8, and the result is 14. H of -2. Here's h is -2. The result is 6. H of 4. Here's 4. The result is 10. Now it goes backwards. Now it says if h of x is 6, then x is what? So now I need to look in the y coordinate spot for 6. Okay, here's 6 in the y coordinate spot, so that means the x is -2. Example 5. We've got two functions, f of x, which is defined as being 2 minus 3x, and g of x, which is 2 times x squared minus 1. And they want us to find the following, f of -2. So I need to find f of -2. That means I'm going to plug in -2 for the x, so I've got 2 minus 3 times -2. That leaves me with 2 plus 6, because I have a negative times a negative, and that equals 8. So f of -2 equals 8. G of 5. So I'm going to find g of 5. That's going to equal 2 times 5 squared minus 1. Exponents come first, so that's 2 times 25 minus 1. And that gives me 50 minus 1, which is 49. So g of 5 equals 49. F of 4 plus g of -1. I first have to evaluate each of these functions at that x. So f of 4 is 2 minus 3 times 4. That gives me 2 minus 12, which gives me -10. So I get -10 for f of 4. G of -1 is going to give me 2 times -1 squared minus 1. Exponents come first. -1 squared is 1. Minus 1. 2 times 1 is 2. 2 minus 1 is 1. So I have f of 4 is -10 plus g of -1 is 1. And then I go ahead and add those. -10 plus 1 is -9. Given the following graph of f of x, find the listed function values. Alright, so they ask for f of -4. Remember, that's our x coordinate. F of -4 is our x coordinate. So I need to find the y coordinate. So I'm going to come over here 1, 2, 3, 4 and go up to my y value. My y value is up at 2. So f of -4 is at 2. F of 0. Here's where x is 0 and my y is also 0. F of 2. I'm going to come over to x equals 2 and find my y value. That's down at -2. f of negative 5 is way out here. My y value at that point is 0. Now it goes backwards. Find x. That means that they're giving us y. So I want to go to my y, and where it's negative 1, where's my x at? Okay, that's kind of in between, so that's going to be half. They want my y at 0. Here's 0. My x is at 0. Okay, so all we're doing is we're pulling these functional points off of the graph. Last one. Given that p of x is 4x minus 7 and w of x is negative x plus 12, find the following values. Okay, there's an x there. That means that's what they want us to find. We need to find x when the y or the function is 41. So here's what we do. That p of x is 41. I'm going ahead and using evaluation again. Equals 4x minus 7. Okay, so I put the 41 in for the p of x. Now I have a two-step equation. I'm going to add 7 to both sides. I get 48 equals 4x. Divide by 4. And x equals 12. So x is going to equal 12 when my function value equals 41. Okay. B. If wx equals negative 1. So wx equals negative 1. That equals negative x plus 12. I'm going to subtract 12 from both sides. I get negative 13 equals negative x. Then I got to get rid of that negative by dividing by negative 1. And x equals positive 13. So when my function equals negative 1, my x value equals 13. P of x is negative 23, so I'm going to plug in negative 23 for p of x. That equals 4x minus 7. Again, I'm going to add 7 to both sides. That leaves me with negative 16 equals 4x. I'm going to divide both sides by 4. And x equals negative 4. And our last example. I have if w of x equals 20. So I'm going to substitute in 20 in for w of x. And I have negative x plus 12. I'm going to subtract 12 from both sides. I get 8 equals negative x. Again, I need to divide that negative 1 out. And x equals negative 8. Now we'll move on to our assignment.